Okay, this is number one from the AP Classroom assignment that I gave you the other day. And this is sort of a recap of the other video, the previous video. Hopefully you watched it at this point. And you remember I told you that if you know this stuff, then you kind of know everything there is to know. Like you should be able to answer all of these questions. And so number one is no exception to that. You look at number one, they give you this, and the question is, which one of these has to be true, and they get some answer choices. Which one of these has to be true in order for this series to converge? And in all the answer choices, it's all about some kind of relationship between X and Y or whatever. And so even though this looks kind of crazy, you know, the fact that X and Y are both positive, well, you know, that's good. That just means that nothing too weird is happening. This right here is our A, and this would be our R. And in order for a geometric series to converge, that has to be true. So the only thing you really had to do in number one was say, all right, well, X over Y squared, you don't need the absolute value because X and Y are both positive. X over Y squared has to be less than one. And then we can just do some regular old algebra here. I can multiply both sides by Y squared. X has to be less than Y squared. That's it. That's the whole thing. All right, number two, kind of the same sort of thing. Again, I can't stress this enough. If you know that stuff, then you can pretty much answer all these questions. This is the series they give you in number two. And then it's another one of those, which of the following, and they give you some answer choices, which of the following must be true. And in every one of the answer choices, it says the sum of the series is this, the sum of the series is this, or whatever. So really it's just asking us what is the sum of this series. Now notice they use a K here instead of an N. That doesn't matter. The K just plays the same role as the N. And so I need to, you know, just figure out what A is and figure out what R is. Well, since K is sort of like my N, then another way that you could write this, and you don't have to write it like this, but you know, you could think of it like this, e to the x to the k, because that and that are the same thing. And if you write it like that, then it just kind of becomes more obvious what all of your stuff is. A, remember A is the first term. So A, since this series starts at k equals 0, if I put a 0 in there, then this just becomes 1, so A is 1. So just from knowing that, you can eliminate two of the answer choices because you know there's going to be a 1 right there in the numerator of your sum. So then the other thing we need to know is the R. The R is just e to the x. And so now I'm just using that little formula right there. S equals 1 over 1 minus e to the x. And then, you know, there are actually two answer choices that have that as the sum. So the other part of the answer choice is something about x, whether it's positive or negative. But, you know, we know this. If this series is actually going to converge, then that number, that value inside that parentheses has to be less than 1. The absolute value of it has to be less than 1. And since e is a, you know, 2.7 whatever, the only way this in the parentheses is going to be less than 1 is if x is negative. Because, you know, if you have a negative exponent, that turns it into a reciprocal. And so it would be 1 over e to the whatever. So x has to be negative. That's the other part of that. And then that is your answer right there. Easy stuff. All right, this is number 5. There are a few that are like this. I'm just going to do one of them. I'm skipping around, obviously. Again, if you have any specific questions about any of them, please feel free to ask me. I just didn't want to, you know, waste your time doing every single problem. This one, it is a geometric series, even though it might not look exactly like it at first. You know, it doesn't really look like that. But it wouldn't take much work. We could make it look like that. 2 to the n plus 1 is the same thing as 2 to the n times 2 to the first over 3 to the n. And so now that you got 2 to the n over 3 to the n, and you got that other 2 sitting out there, we can write this like this, 2 to times 2/3 to the n. And again, we want the sum. We want to know what this equals. And so I'm just using that at this point. And again, to use that, all I need is the first term and the r. And so, I'm going to say a. Now again, this series starts with 1, so be careful about that. Some of them start with 0, some of them start with 1. This one starts with n equals 1. If I put a 1 in right there, that would be 2/3 to the first, which is just 2/3. 2/3 times 2 is 4/3. And then my r is just whatever that is in the parentheses there. R is 2/3. And so now I'm just going to say, all right, S equals A over 1 minus R. 4/3 over 1 minus 2/3. Well, 1 minus 2/3 is 1/3. So I get 4/3 over 1/3. My sum is 4. It's too easy. It's absolutely too easy. All right, 6, 7, and 8 are very similar to number 5, so I'm not going to do all those. Number 9, you get to number 9, it says, which of the following series converge to 2? And this is one of those where you can get multiple answers. So unfortunately, you got to check all these, but the good news is they're not that difficult to check. This first one right here is not even a geometric series. As a matter of fact, not only is it not a geometric series, but the sequence itself, the a sub n part of this, does not converge to 0. That's the nth term test for divergence. This thing fails it, and so this thing diverges, so obviously it doesn't converge to 2. Number 2, you can make this look a little different if you want to, make it look more like that -8, you could bring that out front like that, and then you'd have 1 over -3 to the n. That and that are the same thing. And so, and now it looks more like that. And remember, all we need is the a and the r. Well, my a, notice this series starts with n equals 1, so this would be a 1 here, so this would be -1/3 times -8. So a would be +8/3, r would be -1/3, so my sum would be 8/3 over 1 minus -1/3 would be +1/3. And so that is 8/3 over 4/3, which is 2. So that one's good. That one converges to 2. That last one is even easier. This is just, it's just that. This time it starts with 0. I put a 0 in there. I get a 1 for my first term. My r is 1/2. And so my sum is 1 over 1 minus 1/2. Well, 1 minus 1/2 is 1/2. 1 over 1/2 is 2. So both 2 and 3 converge to 2.